We are going to finish our assessment lecture today, and you're still going to be doing some fun assessments, and then we're going to start anxiety, our first substantive lecture on actual disorders. So we're going from the introductory stuff, such as the DSM and diagnosis and how to understand what mental illness is and what abnormality is, and into, later this week, our first set of actual disorders, anxiety disorders. So let's get started, shall we? All right, let me turn off the music. Okay, so at the end of last class, I had you doing some assessments. Last class, you did self-report inventories. You did some examples of projective tests. And now we're going to learn about screening for organic or neurologic dysfunction. So a lot of times it becomes necessary to try, now it's not always easy, but to try to do assessments that enable us to determine whether or not some of the symptoms that we're seeing somebody present with are purely psychologic and emotional in nature, or whether there is an insult to the brain that has led to the onset of those symptoms, such as a tumor, such as a head injury or other head trauma, or some other form of organic dysfunction. Now, I should say that it's not always easy with one test, and certainly should not be attempted with one test, to discriminate something that is purely neurologic or purely psychologic emotional. But a battery of tests are often used together to try to make this discrimination. So I'm not going to teach you about all of the neurological or organic tests, but I'm going to talk about one that is used fairly widely. Before I get to that, let me talk a little bit about neurological screening as opposed to neuropsychological screening. So neurological screening are the tests that I've mentioned to you in another context. I've talked a little bit in the past in lectures about MRIs, fMRIs, PET scans. So I may have talked about it in passing, but I want to talk about it in a little more detail. So purely neurological screening tests actually in some form measure, oops, there's a bug, measure brain activity, or in some form measure brain anatomy, so we get a picture of the brain. The most often used tests are the functional MRI, otherwise known as the fMRI, the MRI, which is the picture that we take of the brain. It's a high resolution picture. This is known as magnetic resonance imaging. fMRI is functional magnetic resonance imaging. So just a straight up MRI gives you a very high resolution, clear picture of the brain. You get an opportunity to even see overlapping structures that might slightly occlude one another, something you can't see well on a CAT scan. An fMRI measures blood flow. So it's not just showing us a picture of various brain areas, it's showing us how different brain areas are functioning in terms of activity. So I'll get into that a little bit more in a minute. The PET scan, positron emission tomography, is another way to gauge activity level of various areas of the brain. So collectively, these types of neurological tests give us an idea about both the anatomy and functionality of various brain areas. Now we contrast that with what we call a neuropsychological test. Neuropsychological tests require inference. What this means is, in a neuropsychological test, we are not looking at the brain directly. We're not taking images of the brain anatomy, and we're not measuring actual functioning of the chemistry of the brain or the activity of the brain. What we're doing is we're giving people a series of tasks that require that particular brain areas are functioning adequately. And it's called an inference test because on the basis of how well people perform on these tasks, we draw a conclusion, we make an inference, we make a guess about particular brain areas that may not be functioning optimally, because those brain areas typically are necessary to complete the tasks we're giving people accurately, okay? So the Bender Gestalt is a test I'm going to have you do examples of today because it's an often used test. There's actually the Bender Gestalt 2 is a revised version of this that is used more commonly. And it is used to detect what we call organicity, which means it is used to make an inference about potential deficits in the central nervous system, the brain and the spinal cord. It allows us to give people tasks that require them to engage in motor behavior, visual behavior, things of that nature, memory, attention, thinking. And so this Bender Gestalt test is used to make an inference about particular brain areas that may not be functioning adequately, or alternatively, may be functioning above average. This is also used to test giftedness in individuals, and it tests things like people's visual motor behavior, and I'll show you an example where you're looking at an image and you have to copy it. Memory behavior, memory functioning, where you have to be able to copy the images from memory as best you can. Attentional processes, things of that nature. So before we do the actual test, because I like to have you guys try these things, a little bit more about neurological screening. MRI, fMRI, PET scan, things of that nature. The MRI, as I said before, takes a very high resolution picture of brain areas. And it allows the physicians or psychologists, neuropsychologists, to determine whether or not there might be a tumor growing in a particular brain area, whether there might be smaller or larger volume than normal, whether or not there might be lesions, that means you've lost tissue essentially, or other atrophy, things of that nature. So the way it works is it's called magnetic resonance imaging. It creates a magnetic field around the brain, around the head, and it causes hydrogen atoms in the brain to essentially line up. When this machine magnet is turned off, the atoms return to their normal state. But when they do that, they emit certain signals in the process. Those signals are then detected and recorded by a computer. And the computer then translates those signals into a very detailed, accurate picture of the brain. It's so precise that it almost looks like a photograph taken. Rather than a computer image. And the idea is that damaged brain areas may contain inappropriate concentrations of hydrogen. Now, a functional MRI allows us to see not only structures, but also functionality of particular structures in the brain, and it measures blood flow. And the way it does that is by detecting changes in oxygenated blood, right? So we have blood that carries hemoglobin, and that hemoglobin carries oxygen. And oxygenated, the important thing to know about how this works is oxygenated blood emits a different signal than deoxygenated blood. And so that allows us to get an idea of which areas of the brain are receiving more oxygenated blood flow. And from that, we can determine those areas of the brain are more functional in terms of activity level than those that are not. Finally, the PET scan. The PET scan used to be used much more frequently before we had functional MRI. Functional MRI has now become the preferred method for measuring brain activity. The reason is because the PET scan, positron emission tomography is what it stands for, requires that the individual be injected with a radioactive dye. Now, this dye crosses the blood-brain barrier. So we have a blood-brain barrier, you may have learned this in a biology class at some point, that is semi-permeable, meaning it only lets certain things through. This substance, this radioactive dye, is permeable. It does go through the brain, to the brain, through the blood-brain barrier. And so it goes into the person's bloodstream, but then it travels to the brain. The substance emits particles, and they're called positrons. Those positrons, that's why it's called positron emission tomography, those positrons collide with other particles called electrons. When that happens, when positrons and electrons collide, they produce another particle called a photon. That is what the electronic device picks up, the photons. So the computer then records what the electronic device picks up. The more physically active parts of the brain receive more of the substance that's injected, the radioactive dye, and they the active parts of the brain will receive more of that substance than the less active parts of the brain. So in other words, the active parts of the brain are going to emit more of those photons. And so that's going to be picked up by the computer, and you'll see which areas of the brain are more versus less active. The computer translates this into a moving picture of the brain. And so you see levels of blood flow and levels of brain activity represented by different colors on the computer output. Increased activity in certain parts of the brain can be indicative of abnormality if it's too active. For example, in OCD, obsessive compulsive disorder, bipolar disorder, schizophrenia, we'll talk about what PET scan and fMRI have shown about areas of the brain that are too active and could be underlying some of the symptomology of those studies. So, without further ado, I'm going to end the video here. And on the next video, we are going to talk about and do an example of the Bender Gestalt, which is a type of neuropsychological test, an inference-based test. It's not a neurologic test where we're looking at your brain. So meet me on the next video ready to do an activity. Let's go.